for this period. So everyone just participate so this can go quick. So today we're learning a new system to solving equations. Remember, we learned how to solve this last time. This is a system of 3 equations and 3 variables, and would you agree they're all linear? It's x to the first, y to the first, z to the first, yeah? So this is called linear algebra, and mathematicians really back in the day took a deep dive into linear algebra, and they were figuring out all these really cool different methods to solving. We've learned one of them. Wasn't it elimination last time? Yeah. Okay, so all we're doing over this lesson today is learning how to solve a different way, a different mathematician. Gauss discovered this way that we're going to learn today, and it's not hard by any stretch of the imagination. It's annoying in a way. So that even last period was like, yeah, that's not hard. It's just like annoying. And it's not hard because I'm going to teach you how to do it. So we're going to learn what's called method row echelon and reduced row echelon form. And it's using matrices, and really matrices aren't hard. Like I said, it's just understanding things. And my teacher in college, I had to take a whole class called linear algebra, and a huge portion of it was solving, just like we're doing today. And I called my mom crying like every other night, because as soon as I would figure one thing out, it would ruin the other, because my teacher just said, okay, this is what you need to do, go for it. And she didn't give us direction. So as I became a teacher, realized, oh, if you do it like this, it always works, and it never ruins anything old. If I would have just been taught that, it would have saved many tears. Okay, so first things first, what is a matrix? We're going to draw a matrix with these like big brackets, and notice matrices only have the coefficients. See, 3, -1, 1, 3. 3, -1, 1, 3, yeah? Everyone seeing it? 2, -4, 3, 16. 2, -4, 3, 16. 1, -1, 1, 5. So that's what these things are. So you can switch back and forth. So if you see, and we will today switch back and forth. So look, if you start with this, could you write it as an equation? Yeah, you would say, okay, so this is 3x minus 1y plus 1z equals 3. You guys agree? X, y, z equals a constant. Equals a constant. So I'm not going to rewrite the whole thing on that one. Yes?
If it's like out of order, would we put it into the like matrix, I think it's called, in the correct order of x, y, z?
Yes. Okay. So she's saying if like y was listed first in this equation, yes, please put it in the correct order. So x's line up, y's line up, z's, and constants. Very good question. Okay, let's practice. Let's write this in a matrix. So a matrix is brackets. If you draw straight lines, it means something different, and we will see that in the future. So don't draw them like this. That does not mean the same thing as the brackets. So here we go. -1, 2, -3, 5. I don't draw a line in between my equal stuff. I just understand the equal stuff is at the end because it's one more thing to draw in. Then we have a 2, a -1, a 1, a 2, a 1, a 4, a 0. You got to put zeros in place because see the bottom equation doesn't have a z, and then -1. Does everyone see how to convert it to a matrix? We're going to learn in a minute how to take this matrix and use it to solve. We do it by, like I said, row echelon form. So what we find in a minute, everyone look, listen, is we figure out that we actually are going to start by getting a 1 in this position, and then we get zeros below. 1 in this position, zeros below, 1 in this position. We'll talk about it in a minute. Okay, let's switch back, because there's going to be times when you're going to be at a certain point and you're going to say, okay, let's just switch back to the equation form of this. So practice writing this as an equation. Wouldn't it be 2x plus 1y minus 1z equals 3? Everyone? Yeah. 4x minus 1y plus 0z. So I guess I can write that if I want, equals 2. And then -3x plus 5y plus 7z equals -4. And then I could tidy it up. I could take off the ones. If there's a 0, not put it. You know what I mean? But I'm not going to waste our time. We all get the picture here. Yep. Okay, so everyone, what's going to happen is we're going to put it in a matrix, and we're going to get a 1 in this position, and then we're going to use that. So listen to what I'm saying. We're going to get a 1 in this position. I'm going to tell you how to do that. You're allowed to times by a constant. Think about why. In elimination, weren't we also timesing by constants? Yeah. So you can times by constants. So let's say that this is a 7. What would we times by to make it a 1? 1, 7. So we times by reciprocals a lot of times. Now, after you get a 1 in that position, you're then going to work on getting zeros below it. And you always use the 1 that you just got from the when I say diagonal, you'll understand in a minute. You always use the 1 from the diagonal to get the zeros below. So here's what else you're allowed to do. You're allowed to add 2 rows together. So everybody look, if I have a 1 and then whatever, I don't care about the next stuff. And then let's say I have a 2 and then whatever, and then a -3 and then whatever. So let's say I get a 1 in this position right here, check. We then are gonna get a 0 here and here, and we're gonna use the 1. What times 1 is going to add up to be, with that to be 0? 1 times -2. Are you allowed to times by constants? Yes. Are you allowed to add 2 rows together? Yes. So if I times by -2 and add 2 rows together, then I could get a 0 here, couldn't I? Just like elimination. Isn't that what we did with elimination? We added 2, like we said, oh, remember, isn't that literally part of the step is add straight down on elimination? It's actually just elimination a little more tidy in a way. So if I needed to make, look, if I needed to make this 0, what would I need to times this 1 by? 3 to add to that row to be 0. Do you guys see? So to get zeros, I never recommend doing it any other way but the way I'm teaching you so it doesn't ruin your old stuff. So to get zeros, you're going to use this 1 times by the opposite so that when you add them together, it's 0. And if you're like, I'm a little confused. Yeah, you probably should be confused right now. So listen to what our goal is. Okay, we're gonna get a 1 in this position, and then this cannot go out of order. This is where my teacher did not give me directions. She said, get a 1, see what? She said, get 1s along the diagonal and 0s below it. Go. And I would get a 1, and then I'd get a 0 below, and then I'd go to get the next 0, and it would ruin my 0 here. Or it would ruin it, yeah. So I was like, what the heck? So I could never get it actually figured out where I wasn't ruining things I already did. So let me tell you how you can get it right every single time and never, ever, ever ruin what you've already done. Listen to the order. Are you all listening? Yes. You're going to start by getting a 1 here. Then you're going to use the 1 to get the zeros below. You're then going to get a 1 here. You're going to use that 1 to get a 0 below. You're then going to get a 1 here. Then you're going to get the zeros below, which there aren't any. So you get the 1s, 0s below, 1, 0s below, 1s. Does everyone see?
But if you multiply, wouldn't that change it from? You're
going to see how it works. So how do we get 1s? We times by numbers. So once again, if this is a 7, what am I timesing by? 1/7. Okay, we get that. How do we get a 0 below? Well, we add 2 rows together and, okay, let's just do it. So let's just go down to, I guess we'll start with, we're just going to do the first step on this one. Okay, I need you to get a 1 in this position. Now, you're also allowed to switch rows if you want, but that wouldn't be helpful here. Like, what if the bottom row already had a 1? Then I'd just switch row 1 and 3. Do you guys see what I'm saying? All right, so how are we going to make that a 1? Okay, so say a little note to yourself. We're going to take row 1, we're going to times it by a half, and that's going to equal our new row 1. I need you writing yourself notes like this so that if you need help from me, I can try to see what you did, but I probably will just say, let's just redo it because I'm not going to be able to figure out where you went wrong. So here we go. What's row 1 times a half? Times a half, we get 1, 3. You with me? You got to do it to the whole row. You can't just do it to a piece of it. 4 and 6. That's our new row 1. So let's rewrite this. Our new row 1 just became 1, 3, 4, 6. But row 2 and 3 didn't change. So we're going to go -2. 4, 3, -1, -8, 1, -2, -3. Okay, so we've reached our goal of getting a 1 here. We then need to use that 1 to get a 0 right there. I just highlighted it. So why are we using a 1? Because then it's easy. What are you going to multiply 1 by to make it add up to be 0? Okay, so say that. Row 1 times 2 added to row 2 is going to equal the new row 2 we want. See, we're writing ourselves a note. We need a 0 there, so we're taking row 1, we're timesing it by 2, we're then going to add it to row 2 to equal the new row 2. So let's show our work so we don't mess it up. Everyone understands that I'm taking row 1 and timesing by 2. Now, am I actually timesing by 2? No, I'm doing this to manipulate row 2. So I'm not changing row 1 right now. I'm using it for a minute. So times all of these by 2 and write down what you see. So what's row 1 times 2? 2, 6, 8, 12. Now this is what I recommend. Write row 2 as it currently is. So look at row 2 as it currently is. Isn't it -2, 4, 3, -1? Yes? Why do I always recommend this? Because if you do things in your head, you're going to mess up on a negative. And if you mess up on a negative, the rest of the problem will be wrong. You will not know till the end. So you'll do a page-long problem wrong. Okay. And then you'll have to just redo it. That's all there is to it. Okay, so add up like terms. What do we get? Or I mean, add straight down, really. Isn't it 0? 10, 11, 11, and that's our new row 2. See, I have to write myself a note so I don't accidentally change row 1. So now you write it. Say, it's this matrix. The only thing I fixed was row 2. So write row 1 as a 1, a 3, a 4, a 6. So does that answer your question, McKay? Do you see, we didn't really change row 1. So we didn't, yeah, okay. Row 2, though, now is 0, 10, 11, 11. Row 3, we haven't dealt with yet. Negative 8, 1, negative 2, negative 3. Okay, so now from here you'd say, okay, I got a 1 here, I need to get a 0 below. Well, I've already done that. I need to get a 0 here in this order. It can be tempting to like go out of order and say, oh, well, I could get a 1 right there really easily, which we can't. But my point is just, I don't recommend doing it. Is it doable sometimes? Yeah, but I'm not going to do it because I have too much trauma from my college class. Okay, so how are we going to get a 0 right there?
So you said at the beginning if we changed we could change lines?
You mean change rows?
Change rows?
Yeah, the whole row would have to go.
Yeah, could we have changed row 3 to the other one? Or would that not have worked because it was the second one that's a 1? Does that make sense?
Yeah, it wouldn't work. I mean, you need it to be in this position, so that wouldn't be helpful.
Yeah.
Wait, so instead of the first row, we'll find
Got rid of the 8, you would have changed the 1 in row 1.
No, because we only use it, just like we didn't change the 1 here. See, we took row 1 and times by 2, but we're not actually timesing by 2. We're using it to manipulate row 2.
Well, right, but if you want row 3, then you get rid of your 1. Yeah, that's what I'm saying.
Yes, because this isn't officially happening. Like you're not actually timesing row 1 by 2. You're not changing row 1 right now.
So theoretically, you multiply by 2, but you're multiplying it back? Or
No, then you just go back to, okay, what was the, I mean, yes and no, I see what you're saying, but you guys are overcomplicating it. So let me tell you what's allowed. Okay, let me tell you what's allowed. Again, one more time. You can times by numbers to get, you can times by a constant to change a row, yeah? Listen, if you want to, you can add 2 rows together. Yeah, that's allowed. I'm telling you, you didn't know that till now. You can add 2 rows together. That's allowed. Okay, so let's do one more so that we can try to make sense of this. I think seeing it again will help everybody. So we're going to use this 1 right here to make this a 0. So what are we timesing row 1 by? 8. Now understand, we're not changing row 1. We are focusing on row 3, correct? Yes?
Yeah.
So this will not change row 1 in our next step, in our answer. This is only to manipulate row 3. So row 1 times 8, then we're going to add it to row 3 to get equal new row 3. So we're only doing the 8 times row 1 right here, not in officially the matrix. Do you see what I'm saying? Okay. So what's row 1 times 8? 8. 24. Now, this is not new row 1. This is not new row 1. That's what these guys are asking. Well, now that's a problem. But this isn't our new row 1. See, that's not what the formula says. Okay, what's that times 8? 32. And that times 8? 48. And then row 3 currently, I write down the current one so that I don't mess it up. I don't do it in my head. Isn't row 3 currently negative 8, 1, negative 2, negative 3? So now we're going to combine like terms. Aren't we getting 0, 25, 30, 45? And what was that? My new row 3. I always write myself at the end. Remember, that's just new row 3. That way I don't accidentally change row 1 or row 2. We did all of that just to get new row 3. So you would write down now at this point, look back at the matrix you were at. Wasn't that where we were at? Yeah? Mm-hmm. So write down row 1. 1, 3, 4, 6. Write down row 2. 0, 10, 11, 11. And write down your new row 3. 0, 25, 30, 45. See, you got a 1 here, and then you use the 1 to get the zeros below. Okay. Now, our next goal, okay, and I'm going to stop because this was, the only thing I wanted to show is 1 zeros below. I just wanted to show that once, like what you're allowed to do. You just continue. So let's do one from start to end here, okay? Let's start with this next one. Here we go. You guys have got to stay caught up. Don't zone out for even a minute. So here we go. Write this in a matrix. Ready, go. 1, 1, 1, 4. 2, -1, -2, -1. You guys don't even need to look up here. We're writing the coefficients in a matrix. 1, -2, -1, 1. Has everyone written the coefficients in a matrix? You got to make sure, like, if you wrote a +2 where it should have been -2 or something, from the very beginning, you're screwed. You know, like, and you're not going to know that. You're just going to be like, crap, I got it wrong. Okay, I guess I need to redo the whole problem. All right, the goal is, everybody, get a 1 in this position. Check. All right, use that to get a 0 right there. So what are we going to do? Why do we use the 1 above? Just because. That's what I'm telling you will not ruin stuff you already need. So we're going to take row 1 and times it by -2. We're going to add it to row 2 to be equal to our new row 2. Okay, so everybody look at your eyeballs. I need you all looking right now at row 1. Is everybody's eyeballs looking at row 1? We are timesing by -2 and writing it down so that we don't mess it up. This is us like showing our work. So what's row 1 times -2? -2, -2, -2, -8. If you mess up on a negative at all, like I said, you can't make one error. No errors. Okay. Currently, I repeat, currently, row 2 is that. I'm writing it so I can line things up. If I do it in my head, I mess up and it is not worth redoing an entire problem. I'm not going to be able to look at your work, you guys, and say, you went wrong here. I will not be able to. I will say, you and I can redo it, but that's the only way I can help you. Okay, add up like terms. What are we getting? 0, -3, -4, -9. Write yourself a note. It was row 2. Okay, so now let's go like this. Row 1 didn't change. 1, 1, 1, 4. Row 2 just became 0, -3, -4, -9. Row 3 is still 1, -2, -1, and 1. So we got a 1 here, we got the 0 below. Our next goal is to get a 0 right here. We use the 1 from the diagonal to do it. They're going to need to add together. To get 0, I only ever recommend adding 2 rows together. So here, I mean, I don't know how else you'd get 0. That's the only way, I guess. So that's kind of a silly statement. Okay, so what are we doing with row 1? Times by -1. We're then going to add it to row 3 to equal our new row 3. So everyone look at your eyeballs at row 1 and times by -1. -1, -1, -1, -4. Did everyone agree?
Yep.
If you times row 1 by -1, you get -1, -1, -1, -4. Current row 3 is 1, -2, -1, 1. So now I'm getting, I wrote down the current one, 0, -3, -2, -3, and that's my new row 3. Okay, let's write our matrix now. Row 1, this was the matrix before. It's still that matrix. We just have a new row 3. 1, 1, 1, 4. Row 2 is 0, -3, -4, -9. And row 3 is 0, sorry, right here. 0, -3, -2, -3. I'm going to wait for everyone to get here.
I'm there. I'm here.
Now, how many of you are tempted to say, let's just, we know that, right? Listen, we need a 1 here and then zeros below, yeah? Our next goal is to get a 1 here. Now, then after that, won't we be getting a 0 here?
Yeah.
So a lot of people will be saying, and this is, like I said, I'm not telling you you can't do it, but I'm not going to do it because I have too much trauma. Wouldn't you agree if I add row 2 to row 3, it's going to create a 0 where I need it? If you want to do it, cool. But I'm not going out of order based on trauma of the past, so I'm not doing it. I'm going to instead get a 1 right here. How do I get a 1? The only way to get a 1, I do not ever, listen to what I'm saying. Do not get a 1 by adding rows together. Don't freaking do it. Just times by a constant. I promise you guys, this is why when I went about it randomly, I had so many tears. So how are we going to get -1/3 to be a 1? So write yourself a note. We're going to take row 2 and times by -1/3, and that's going to equal our new row 2.
But that, oh, never mind.
And it's not going to be pretty for a minute, and that's going to be okay. So 0, look, I'm timesing by negative a third. Isn't it still 0? I'm timesing negative 3 by negative a third. What will that be? Positive 1. Negative 4 times negative a third is 4 thirds. Negative 9 times negative 1 third. 3. Look, what if you wrote down negative 3? The entire rest of the problem is going to be wrong. So you cannot make errors. You just can't. So row 2, let's write it. So now we're looking at this. Row 1 is still 1, 1, 1, 4. Row 2 just became 0, 1, 4 thirds, 3. And row 3, remember we were here before, is 0, negative 3, negative 2, negative 3. So I repeat, you're going to be sick of me saying this. We got a 1 here, 0's below. We got a 1 here. What's the next step? 0 below. How do you get a 0? I only recommend using the 1 from the diagonal to get a 0 here. So we're going to take row 2.
Why do you recommend that?
Because it will not, this process never ruins any of the 1s and 0s from previous. So this will never ever ruin anything you've already done. Do you see what I'm saying? When people start doing random stuff, they'll go, oh crap, but that ruins my 1. Oh crap, but that ruins my 0. Okay, row 2 times 3, because of this 1, it's really easy to get 0s if you're using the 1. Okay, so, and I'm using it from the diagonal. I'm not gonna, yeah, is there a 1 above that? Yeah, but that would ruin my 0. So just listen to what I'm saying. Always use the 1 from the diagonal. So row 2 times 3 is then gonna be added to row 2, oh no, whoa. Row 3 equaling my new row 3. Okay, so my brain is looking here. I'm timesing that by 3 and writing down what I get. Isn't it 0? Look, I'm timesing by 3. Am I actually timesing by 3? No. I'm doing that to manipulate my row 3. So don't I get a 0, a 3, a 4? Do you guys understand why they're saying 4 so easily?
Yeah.
The 3's divide out. And then 9? And then we're adding it to row 3. Row 3 is currently 0, negative 3, negative 2, negative 3. I write down the current row 3 so that they're lined up so I just don't make errors. So that's 0, 0, 2, 6, and that's row 3. Okay, I rewrite my matrix again. We were here. Row 1 didn't change. 1, 1, 1, 4. Row 2 didn't change. We used it, but it didn't change it. 0, 1, it's still 4 thirds, and it's still 3. Row 3 just became 0, 0. We're so close, guys. 2, 6. We got a 1, 0's below. 1, 0's below. We now need a 1 in this position, and we only get 1s by timesing by constants. So what are we going to times row 3 by? 1/2, and that'll equal our new row 3. So that'll be 0, 0, 1, 3. If I times it by 1/2, true? Okay, so row 1 is 1, 1, 1, 4. Row 2 is 0, 1, 4 thirds, and 3. And row 3 just became, that's my new row 3. See, if I don't write it right next to it, I start to second guess it. 0, 0, 1, 3. Now look, we've reached our goal. This is row echelon form. Don't we have 1s along the diagonal and then 0s below? Okay, now look, we actually can solve from here. So here's why. Look at the bottom. Work your way from the bottom upwards. What is the bottom statement? 0x plus 0y plus 1z equals 3. Isn't that what the bottom says? So what is that? Z equals 3. Cool. That's always going to happen, right? That's why you got 1s and 0s, so that this would happen. Do you guys see? Are you seeing it?
Yeah.
Now what's the next statement? 0x plus 1y plus 4 thirds z equals 3. So now, look, we can use substitution, like back calculation, to finish. So we don't need 0x. We have y plus 4 thirds, isn't z 3? Equals 3. So that would be y plus 4 equals 3. Once again, I have the math ability to go 3 and 3 divide out. That's why I said 4, because I know that that's how fractions work. When timesing, yeah? Okay, so now from here we'll subtract 4. So y equals negative 1. Then we're going to go to our very, very top and write down that statement as a statement. 1 x plus 1y plus 1z equals 4. So that's just x plus y plus z equals 4. Let's plug in what we know. We don't know x, but we know y is negative 1. We know z is 3. So that's x plus 2 equals 4. Subtract 2. X equals negative 2. We have not done anything different. We've done a different method. We still found one independent solution of 3 planes.
It's just 2, not negative.
It's just 2. Okay, so make that a positive. So now we write our independent solution as 2, negative 1, because it's x, y, z. So 2, negative 1, 3. It's just a new method. We solved just like we could have solved with elimination. It's just now we use this method. And yes, if you're wondering, because there's always this kid that's like, I'm just going to freaking do elimination on the whole test, and like, it is what it is. Like, it literally says in the instructions, if you do not use the method listed, you get a 0. So if they say use echelon form, they require it. See, look, none of that was hard. It was just annoying. Yeah.
It's not hard work, it just sucks.
Okay, again.
Why wouldn't we?
Again. Some people like this method better.
No way we like this method better.
Again. 1, negative 1, 1, 5. I'm going again. 0, negative 2, 1, 6. 0, 2, negative 2, negative 12. Write it as an augmented matrix. I'm going to leave you in the dust if you guys don't catch up. Write your coefficients.
Oh, this
Oh, nice. They're being too nice to us here, aren't they?
yeah, this one's super
Too
sweet.
nice. Too nice to be not letting us.
So you say 1 here, 0's below. I'm not going to get tempted to go out of order. That is the order. Well, good. It's already done. I'm going to get a 1 right here. We get 1s by not adding. I don't recommend it. Don't do it. Times by a number to get a 1. So row 2 times, we need that to be a 1. Negative 1/2 will equal my new row 2. So that'll be, if I'm timesing by negative 1/2, this is so my brain doesn't mess it up. I'm getting 0, 1, negative 1/2, negative 3. Okay. So row 1 is still 1, negative 1, 1, 5. Row 2 just became 0, 1, negative 1/2, negative 3. Row 3 hasn't changed. 0, 2, negative 2, negative 12. You get a 1 here, 0's below. 1 here, you then get a 0 below, and to do it, you always use 1 from the diagonal. So row 2 times,
Negative 2.
you're trying to add it to that to be 0. So negative 2 plus row 3 will equal our new row 3. So I'm looking at row 2 and timesing by negative 2. That'll be 0. Negative 2, 1, 6. I times row 2 by negative 2. Does everyone see that I just then wrote 0, negative 2, 1, 6? Because I times row 2 by negative 2. We're timesing this by negative 2. Why? So we can add it to be 0. So I did that times negative 2, wrote down 0. That times negative 2, wrote down negative 2. That times negative 2, wrote down 1. That times negative 2, wrote down 6. Okay, row 3 currently is 0, 2, negative 12. So when I add straight down, I get 0, 0, negative 1, negative 6. That's my new row 3. All right, I'm writing it again. So I was here, I only changed row 3. 1, negative 1, 1, 5. 0, 1, negative 1/2, negative 3. Row 3 just became 0, 0, negative 1, negative 6. We're so close to being done. You're right. 1 here, 0's below. 1 here, 0's below. You need a 1 here. We're timesing by a number to get that. So won't it just be row 3 times negative 1?
Yep.
So that would be 0, 0, 1, 6. 1, negative 1, 1, 5, 0, 1, negative 1/2, negative 3. And row 3 just became 0, 0, 1, 6. Once you have 1's along the diagonal, 0's below. 1's along the diagonal, 0's below. We've reached row echelon form, which then you can finish by writing statements. So what will be the third statement? Z equals 6, because it's X, Y, Z. Do you guys see why we said that? Circle it, okay? Next one's going to have to be, I have to write it out. I have 0x plus 1y minus 1/2 z. My eyeballs are there, and I'm writing down what I have, equals -3. I'm writing it back as an equation now. Is everyone with me? I didn't write 0x because it felt silly.
Yeah.
Somebody would say y minus 1/2 times 6 equals -3. So that's y minus 3 equals -3. We'll add 3. Y equals 0. We then go to the top one and write what we have. X minus y plus z equals 5. X, y, z equals 5. Do you guys see why I wrote it like that?
Yeah.
Now plug in what we know. X minus 0 plus 6 equals 5. X plus 6 equals 5. So x equals -1. We found one independent solution by method row echelon form. They call it Gauss elimination because Gauss is the mathematician that discovered it this far. -106. Okay. You good out there, everyone?
We're good.
Okay, now we can do it with two variables. Let's do it. So coefficients 2, 3, 6, 1, -1, 1/2. Now, if we need a 1 in this position, wouldn't you agree that this is already a 1? Then switch row 1 and 2. You can switch rows. Of course we can. If this was listed on top of this, it wouldn't matter. It's the same solution.
Mrs. Bowman, when can you not switch rows?
You can always switch rows.
You can't always?
No, you can always switch rows, yeah. So 1, -1, 1/2. 2, 3, 6. I just switched row 1 and 2. So then my brain goes back to, I need a 1 in this position, check. I then need a 0 below, in that order. So that times what will add up with that, 2 to be 0. So row 1 times -2 needs to be added to row 2 so that we get our new row 2 with a 0. So row 1, my personal eyeballs are right here, timesing by -2. I get -2, +2. If I'm timesing by -2, is that -1? Current row 2 is the 2, the 3, the 6. So I'm getting 0. You know what I did last hour? I said 6, but it's 5, right? You can see how my brain did it, though. You got to be careful. And then 5. That's my new row 2. So row 1 is 1, -1, 1/2. Row 2 just became 0, 5, 5. So we get a 1 in this position, 0 below. We now need a 1 in this position. We get 1s by timesing by numbers. So what are we timesing by? Row 2 times a 5th, equaling new row 2. So it'll be 0, 1, 1, won't it? 1, -1, 1/2. 0, 1, 1. Once you have 1s along the diagonal and 0s below, you've done row echelon form. So now we can solve by setting up statements. What is the bottom statement? 0x plus 1y equals 1. So what is that? Y equals 1. The next statement would be x minus y equals 1/2. X minus 1 equals 1/2. We're adding 1. X equals 3/2. So we have one independent intersection point. I know it's linear. I know it's 2 lines because it's now back to 2-dimensional math because it's just x and y. 3/2, 1. Cool. Good stuff. Now we're still going to have infinite solutions and no solutions with this method come up. It's just a new method. That is, the solutions look the same. So look at what's going to happen. Listen, because this is actually really easy. How are you going to know it's infinite solutions and what do you do? The exact same thing we would normally do. Watch. So you would be going along. Pretend with me a scenario. Pretend we were going along and we found a 1 here and then 0 below. 1 here, 0 below. And then while doing that process, it created a 0 right here naturally. So the next step would be like, I need a 1 right here. you can't create a 1 by anything other than timesing by a number. Isn't 0 times anything still 0? So you're like, that can't become a 1. Well, then what's going on? Well, then it just depends from there. Okay, so like, what's the bottom? So look, at this point, isn't it 0x plus 0y plus 0z equals 0?
Yeah.
So isn't that just 0 equals 0? So your variable canceled out. If you have 0 straight across, you have 0 equals 0, which means it's infinite solutions. Now watch, we can't just say infinite solutions. Remember, we then write like this. Here we go. We say, okay, we know it needs to be x equals an equation, and it can only have z's in it. Y needs to be an equation, and it can only have z's in it. And z's get to stay z's. So the bottom isn't helpful, is it? But look at the next statement. Let's write what that says. 0x plus 1y minus 2z equals 0. So that would be y minus 2z equals 0. Can you guys get y by itself and have it be an equation with z's in it? Yeah. Add 2z. So you have y equals 2z. Cool. So we now know it needs to be x equals an equation with z. We have y equals 2z, and then z gets to stay z. So we're almost finished. We now go to the top equation and write down what that is. X plus 2y minus z equals 1. X plus 2y minus z equals 1. Do you guys see why I wrote that? Now get x by itself. So subtract 2y, add z. So x is equal to 1 minus 2y plus z. We now know exactly what to do. We saw this last time. If y is there, that's not allowed. It can only have z's. We're going to put what y is as a z. Isn't this what y is as a z?
Yeah.
So replace it. We have 1 minus 2 times 2z plus z. So we have x equals 1 plus, no, it was minus 4z plus 1z. So isn't that x equals 1 minus 3z?
Yeah.
There it is. There's our answer. X equals 1 minus 3z. There's our infinite solution one. Yes.
If we use a equation with one
What do you mean by that?
like using them to find the other variables, you know what I'm saying? Like the ones in our things, can we, if we already use that one for like.
You can use it, yeah, more than once, yeah. Okay, look at what's gonna happen with no solutions. I hope you're paying attention because then people do some weird stuff. Okay, let's say that we listen so that you can see the scenario because it's not gonna just start like this. Look, you're gonna get a 1 here, 0 below, 1 here, 0 below, and everything will have gone good. And then naturally, it all of a sudden created a 0 right here. Now remember, from here then, look at this statement. Like, look, what if you got here and you're like, oh crap, I can't get a 1 here. Then you'd say like, then what's the deal? If I can't get a 1 there, what's the deal? Well, it's either infinite solutions or no solutions. So you have to look at the bottom statement. Isn't that 0x plus 0y plus 0z equals 2? So 0 equals 2 is an inconsistent statement, which means no solution. And at that point, you're just done, no solution. So look, if the bottom has zeros straight across, the first 3 would have to be zeros. It's fine if you get a 0 here and a 2 here. Can't you make 2 a 1? Yeah, you times it by a half. So don't be mistaken. Just because you see 3 zeros on the bottom, no. It's if you see 3 zeros in a row, in that order, and then it equals a number, it would be no solution. Okay, let's just listen to the next thing. So Gauss figured out this far. Gauss was like, let's get a 1 here, 0 below, 1 here, 0 below, 1 here. And then another mathematician came along, and then Gauss always just then used back substitution like we were doing. Then this other mathematician with the last name Jordan was working with him, and he's like, hey, what if we just get a 0 now here and here using this one? And then what if we then get a 0 here using this one? Then won't we actually have the solutions? And he's like, oh yeah. See, look. So this is called reduced row echelon form. It's known as Gauss-Jordan elimination because, like I said, it took the Jordan to be like, why don't we just keep going? Because then look, there's the solutions. Isn't that, everyone, isn't that just x equals 2, everyone, yeah?
Yeah.
Because I'm not going to write plus 0y plus 0z. That feels silly. And then I have y, don't I? 0x plus 1y equals negative 1. And then on bottom, I have 0x plus 0y plus 1z equals 3. Then you just have the solutions, these. The x, y, z solution. Okay, let's do it. Let's do Gauss-Jordan. You got to go in the correct order. 1, 0 below, 1, 0 below. Then 1, 0 above, 0 above. Here we go. Let's do it. Okay, 3, 4, 12. Negative 6, negative 8, negative 24. They want us to do reduced row echelon form. So let's get a 1 right here. So what are we timesing by? 1/3 times a third times a third. Let's write the new matrix. 1 4/3 4. Okay, then you're going to say, okay, now that I got a 1 here, I'm going to use it to get the 0 here. So what are we timesing row 1 by? We're then adding it to row 2, equaling new row 2. Row 1, everyone, I'm just going to put a purple box around it. We're timesing all of those by 6, but we're not actually changing it. We're just doing it for a minute. So don't I get a 6? Now let's say you're like, wait, what is that? If it's not a decimal, then you could do it in your calculator. So you could do 4 divided by 3, hit enter times 6, and it tells you it's 8. 24. Row 2 currently is negative 6, negative 8, negative 24. And in this one, 0, 0, 0. The whole thing became 0. The whole bottom became 0. So what do we have? 1, 4/3, 4, and then 0, 0, 0, don't we? So now we know that's 0x plus 0y equals 0, 0 equals 0. Oh, it's infinite solution. So we can't even do reduced row echelon form. We have to just finish the infinite solution one. So then the bottom's not helpful. It tells you it's infinite solutions, but that's not going to help you with your equation. Now, isn't this one just x, y?
Yeah.
Remember we wrote these ones as x can be anything, but y needs to equal mx plus b, an equation with x's. So let's see what the top statement is. Isn't the top statement x plus 4/3 y equals 4?
Yeah.
So now we can get y by itself. 4/3 y equals 4 minus x. I'm going to not divide by 4/3. I'm going to be smarter about it so my life is easier. I'm going to times by 3/4 to both sides. So y equals 4/3 times 3/4 is 3. And then we have negative 3/4 x. So that would be your infinite solution. X comma y equals negative 3/4 x plus 3. Now, could you have actually chose to do y can be anything, x needs to be any equation with y's? You actually can. Doesn't matter which one you pick. So that would actually have been easier, wouldn't it?
Doesn't matter when there's 3 of them,
No, it doesn't. But we always do z, so we got to do the same one so we can compare answers. So I'm always going to do z. Do you guys agree that this could be then x equals, look back to here, back to that statement. Wouldn't that just be x equals 4 minus 4/3 y, comma y? That would have been easier. You can do that. We just got to all agree that like we got to do it one way or the other, or we can't compare answers. On a test, I have to write down all answers because I have to be able to say, well, both of those are equally correct. Which one did they pick? Okay, moving on. Here we go. Let's do reduced row echelon form for real. Lock in and just take a deep breath, do some meditation before each problem, and say it's going to be okay. This is going to take some time. And you cannot mess up. You cannot mess up.
That's not an option.
It's not an option. Here we go. 1, 1, 1, 3. 2, negative 1, 1, 0. You guys have got to stay locked in or you're going to be like, wait, it's so easy to get lost. There's a lot going on. Put your coefficients in. And you guys can just look at your paper to put in the coefficients. That'll be quicker.
I wrote it too cramped. I have to restart.
Yeah, don't write it too cramped. We need a 1 right here. Now watch, because I'm going to sometimes hit 2 birds with 1 stone now that we're advanced. Okay. So for 1, isn't the goal to get a 0 here and here?
Yeah.
Okay, we always use the 1 to get the zeros. So let's just focus on the 2 for a minute. We're going to take row 1 and times by -2. We're then going to add it to row 2 to equal new row 2. Now focus on -3. We use this 1 to make it 0. So what are we going to times row 1 by also?
Negative 3.
3. And then we're going to add it to row 3 equaling new row 3. So I'm just writing both formulas right here so that I can just do them both and then write in new row 2 and new row 3. Okay, everyone, right here is where I am looking and I am timesing row 1 by -2. So let's write down what that will be. -2, -2, -2, -6. Does everyone see how we're just now answering what it says right here? We're taking row 1 and timesing by -2. Write down current row 2 under it. 2, -1, 1, 0. And then add up like terms. Or no, I keep saying that, but really it's add straight down. Like these all look alike terms, I guess, really. So I shouldn't say that. 0, -3, -1, -6, and that's my new row 2. I need to make note of that. Look back at the pink box. We're now going to do this next equation. Pink box. We're timesing all of those pink box numbers by 3. So what will we have? 3, 3, 3, 9. Do you guys see how I took the pink box and times all those by 3?
Yeah.
Then row 3 is -3, 5, 7, 7. I write down current row 3. So now I'm getting 0, 8, 10, 16, and that's my new row 3. We'll then pause for a good long time and make sure everyone gets caught up. Rewrite row 1. The pink box hasn't changed. We used it to change the others. So we still have a 1, a 1, a 1, a 3. Row 2 is now 0, -3, -1, -6. Row 3 is 0, 8, 10, 16. I'm going to give everybody a minute to catch up. So we get 1 here, 0's below. The next step is always then getting the 1. Do not move on to the 0. You got to get a 1 there in that position. We're trying to get a 1 along the diagonal. The only way we're going to get 1s is timesing by a number. So if we need a 1 right here, what are we timesing row 2 by? -1/3, and that'll equal new row 2. So all of these are getting timesed by -1/3. And I'm going to write down my matrix again. So row 1 is 1, 1, 1, 3. Row 2 is now 0, 1, 1/3, 2. 0, 8, 10, 16 is still row 3. So we get a 1 here, 0's below, 1 here. We then use that 1 right there to get a 0 for 8. Okay, so what are we timesing row 2 by? -8. We're then adding it to row 3, equaling new row 3.
Isn't it -1/3? And negative?
No, because there was negative divided by a negative, or times a negative.
Oh, I forgot the.
So you'll see that, like, from here on out, your whole problem would have been wrong. Do you see? You just have to be so careful. It sucks. Okay, row 2 times -8. Do you guys understand? I'm looking at the blue box and timesing those numbers by -8. Okay, let's do it. So we get 0, -8. No, don't do decimals. -8/3 and -16. Write down current row 3 as it currently is. 0, 8, 10, 16. Okay, here we go. Let's add straight down. 0 plus 0 is 0. 8 minus 8 is 0. Now look, I'm going to have to go off to the side. I'm adding up that. So I'm going to go like this. Negative 8/3 plus 10 over 1. We do have to be able to add fractions. So now I'm going to get a common denominator. I'm going to times by 3. So that's negative 8/3 plus 30/3, which is 22/3.
Equals 0.
And then
Time it is.
0. Net is not no solution. We're not done. Okay, we'll write down, oh, that was new row 3. Okay, here we go. I'm writing down row 1 as a 1, a 1, a 1, a 3. I'm writing down row 2 as 0, 1, 1/3, 2. And now row 3 just became 0, 0, 22/3, 0. Nope, it is not infinite and it's not no solution. It's not 0, 0, 0. Do you guys see what I'm saying? Now do not stop. If they say reduced, if they use the word reduced row echelon form, you got to keep going. Which we weren't done anyway. Don't we need a now 1? And we get a 1, 0 below, 1, 0 below. Now we need a 1 in this position. Correct. You got to keep track of the order I'm telling you. How do you get a 1 right there? But you got to do it to everything on that row. So times by 3 over 22. Times by 3 over 22. Times by 3 over 22. We're lucky that they all equal 0. Good point. So we have a 1, a 1, a 1, a 3, a 0, a 1, a 1/3, a 2. Now we have 0, 0, 1, 0. Luckily, you got rid of that nasty fraction.
Yeah.
Do not use back substitution. They want us to do reduced row echelon form. So I'm going to review again. You get a 1 here, 0's below. You then get a 1 here, 0's below. You then get a 1 here. Now listen to the steps. You then need to get 0's here in that order. So you're going to use the 1 from the diagonal to get a 0 here. So what are we timesing row 3 by? Negative 1/3. Isn't that what's going to add up to be 0, everyone?
Yeah.
And we're going to add it to row 2 to equal the new row 2 that we want with a 0 in the correct place. So I'm timesing, yep. I'm timesing these by negative 1/3, but not for reals, just to get a 0 in the other one. So then I get a 0, a 0, a negative 1/3, and a 0. Write down current row 2 as it currently is. I'm pointing a purple arrow at it. Currently, it's 0, 1, 1/3, 2. Now we're going to add up like freak. I can't imagine. I hate that I'm saying that. Add straight down. 0 plus 0 is 0. 1 plus 0 is 1. Isn't that now 0? 0 plus 2 is 2, and that's my new row 2. Okay, let's write it in. So we have 1, 1, 1, 3. Remember, we're writing row 1 the same. Row 2 just became 0, 1, 0, 2. Row 3 hasn't changed. It's still 0, 0, 1, 0. Now, we got a 1 here, 0 below. 1 here, 0 below. 1, 0. Now, don't I need a 0 here?
Yeah.
What?
Why is that not no solution? Because 1 equals 0.
So, z equals 0? Right. Okay. So now we're going to get a 0 here using the 1 from the diagonal. So what are we timesing row 3 by? Negative 1. We're then adding it to row 1, equaling new row 1. If you were to stop there, you wouldn't be there yet. They'd make me dock you because this is not reduced row echelon form. So I'm going to box it. I'm looking at this pink box and timesing those by negative 1. So don't I get 0, 0, negative 1, 0? The pink box times a negative 1. 0, 0, negative 1, 0. Then row 1 currently is 1, 1, 1, 3. We're adding straight down. I wrote down row 1 currently. So that'd be 1, 1, 0, 3, and that's my new row 1. So it's this, but with a new row 1, 1, 1, 0, 3. Row 2 and 3 didn't change. 0, 1, 0, 2. 0, 0, 1, 0. We got a 1 here, 0 below. 1 here, 0 below. 1, 0's above. We now, all we need is a 0 right there. And we always use the 1 from the diagonal to get the 0. So we need this to be a 0. So won't we take row 2 and times by -1?
Yeah.
Added to row 1 equaling new row 1, which will then finally be done. So I'm going to do pink box. I'm timesing this by -1. So my brain stays in the right spot. 0, -1, 0, -2. Current, I repeat, current row 1 is 1, 1, 0, 3. So I'm getting 1, 0, 0, 1. And that's my new row 1. 1, 0, 0, 1. Then we're doing this, but with new row 1. So row 2 is 0, 1, 0, 2. And then 0, 0, 1, 0. Which, look, now we have the 3 solutions, don't we? 1's along the diagonal, 0's above and below. So what would be our solution? X equals 1, Y equals 2, Z equals 0. 1, comma 2, comma 0. Ding, 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 ding.
This is so much fun.
That's actually kind of fun.
It is fun.
This is not.
All right.
This one's better than no solution.
Would you guys like to see another one, or do you think you get it? You're sure you got it, though? You're sure you don't want to see, like, an infinite one, or?
You cannot, I cannot express how
Uh-huh. Well, yeah, exactly. Okay, listen. Remember that story problems you might have to set up yourself? Do you want to set up one, or you guys like, you're good? Okay, read this problem. I would have to ask the student so that I didn't disrespect them how to say their name. So I don't know how to say it correctly. Wants to make a party mix consisting of almonds, cashews, and peanuts. He wants to make 10 pounds with a budget of $35. So he's like mixing them, correct? To make like a party mix, they're calling it, yeah? So it's pounds. So we're gonna have X plus Y plus Z equals what? How many pounds? 10 pounds. That's true, right? If we're adding up, we're putting in a bag of 10 pounds, some almonds, peanuts, whatever, it can only equal 10 pounds, yeah? Now let's do a money truth statement. So it was almonds were $7. So you'd say 7x plus money 5y, see? Plus 2z equals a money statement. It's going to cost $35. True?
Yeah.
Now, think with me. Is that accurate? Because see, it has to be the same. Do you guys agree it's money times X, money times Y, money times Z? Will it equal a money statement? Yeah, it will, right?
Yeah.
So we're good. Just making sure. Okay. I was just making sure because sometimes, if it doesn't equal the correct thing, you have to convert it or whatever. You have to times by 10, 35 times 10. But we're good, I think. Yeah? Are we?
Yeah.
Okay. Now, the third statement is missing. So you can't solve a system of equations with three variables unless there's 3 statements. So he also wants 2 times as many cashews as peanuts. You pretend that was in there. It wasn't solvable otherwise. 2 times as many cashews. What was cashews?
Cashews is Y.
So is it Y equals 2Z or is it Z equals 2Y? Because he wants twice as many cashews as peanuts, and that would be what it would be saying. Because these are the peanuts, right?
Yeah.
And we want twice as many. So, right, Y equals 2Z. And I'm going to make a point here. If you're asked to solve this with reduced row echelon form, you would say, oh, I need to fix the order. It has to be X plus Y plus Z equals a number. X plus Y plus Z equals a number. So I would have to subtract 2Z. And then call this 0x plus y minus 2z equals 0. So then you would set up your matrix. We're not going to solve this one. Let's just set up our matrix. So it'd be 1, 1, 1, 10. True?
Yeah.
7, 5, 2, 35. And then it'll be 0, 1, negative 2, 0. And now we could solve by row echelon form or reduced row echelon form. That's the end of the lesson. 6.3, go start doing it and be very careful because I'm telling you, if you come to me and say, I don't know how I got this one wrong, okay, let's just go redo it. And I'm fine with that. I'm happy to redo it with you. But just understand, I won't be able to figure out where you went wrong. Okay, ready, set, go.